identifying the source of a problem in software applications and finding a way to resolve it. This involves a systematic search for the root cause of the issue and implementing appropriate fixes. And this report provides supplemental materials to aid in the understanding and practice of software troubleshooting. So we have in here key concepts in software troubleshooting. So first is identification. So under this, it recognized and clearly defined the problem. Use error messages, logs, and user reports to gather information. Another is gather information. So you should identify symptoms, affected systems, and any recent changes. Second here is diagnosis. You should analyze the problem by determining its root cause using various diagnostic tools, and then use debugging tools like debuggers, log analyzers, performance profilers, and network analyzers. And the third one here is the resolution. Develop and implement a solution. So with this, you need to apply code fixes, updates, patches, or configuration changes, or use version control. Ensure changes are tracked and can be reversed if necessary. Is verification. So test the solution, ensure the problem is resolved through testing. Then conduct regression testing. So check for side effects on existing functionality. And lastly, fifth, the documentation. Record the problem and solution. So maintain a knowledge base for future reference or share findings that help other team members and future troubleshooting efforts.
Types of software issues: bugs, errors, flaws in the code cause incorrect or unexpected behavior. Examples: syntax errors, logic errors, runtime errors. Second type of software issues is performance issues. It is described as slow or unresponsive software due to inefficient code or resource management. Common causes of performance issues are memory leaks, CPU overuse, I/O bottlenecks. Third type of software issues is the compatibility issues. Software conflicts with other programs, hardware, or operating systems. Arises from updates or changes in dependencies. Last type of software issue is the security vulnerabilities. Weaknesses in the software can be exploited by attackers. Examples of security vulnerabilities are buffer overflows, SQL injection, cross-site scripting.
Number 3. Diagnostic tools and techniques. Debuggers. Purpose: identify and fix bugs by allowing step-by-step code execution. Examples: GDB, Visual Studio Debugger. Log analyzers. Purpose: interpret and analyze logs files to identify patterns and issues. Examples: Logly and Splunk. Performance profilers. Purpose: monitor and analyze software's performance to identify bottleneck. Examples: Perf and Visual VM. Network analyzers. Purpose: diagnose network-related software's issue by analyzing traffic. Examples: Wireshark and Fiddler. Common techniques. Code review. Peer review of code to find and fix error. Regression testing. Testing existing functionality after changes. Unit testing. Testing individual components of the software and isolations. Integration testing. Testing combine part of the software to ensure they work together.
Case studies. Resolving a memory leak in a web application. Problem. Web application experiencing slow performance over time. Diagnosis. Profiling tools indefinitely. Memory leak. Resolution. Optimized code to manage memory, allocation, and the location. Verification, monitoring the application post-fix to ensure stability. This case study, the stage from a problem identification to resolve and verification are clearly outlined, providing a comprehensive understanding of how a specific technical issue has addressed. Fixing a compatibility issue with a new OS update. Problem. Software casing after an operating system update. Diagnosis long files, pinpoint compatibility issues. Resolution. Update the software to be compatible with the new OS version. Verification. Test on multiple OS version to confirm the fix. This case studies highlights the step taken to diagnose and resolve a software compatibility issue, embarrassing the throughout testing needed to verify the effectiveness of the solution. Overall, case studies offer variable in highlights into real-world problem-solving scenarios, serving as trackable example of strategies and methodologies applied to overcome challenges in various domains.
Best practices are established methods or techniques are recognized as the most effective and efficient way to accomplishing a specific task or goal. There are four best practices. First one is proactive monitoring. Implement monitoring tools. Detect issues before they impact user. Regularly review logs and performance metrics to catch potential problem earlier. For monitoring, this involves using tools to keep an eye on the system and detect issues before they become critical. For example, a website administrator might use monitoring software to track the performance of their website and receive alerts if there are any issues such as slow loading times or service error. Regular updates. Keep software and deficiency up to date. To avoid known issues, test updates truly before developing in a production environment. Regular updates. This refers to keep software and its defenses current to avoid known issues. For instance, a company might regularly update its operating system, security software, and applications to protect against potential security and ensure optimal performance. The next is user feedback. Collect and analyze user feedback to identify current issues. Engage with users to understand their pain points and improve user experience. And user feedback. This practice involves collecting and analyzing feedback from users to better understand their experience and needs. An example is a software company gathering feedback from customers to identify common user interface issues and then making improvements based on that feedback. And the last one is detailed documentation. Maintain comprehensive documentation of common issues and their resolution. Create a knowledge base to help team members through such efficiency. Detailed documentation. This refers to maintain comprehensive recording of common issues and their resolutions, and creating a knowledge base to aid in troubleshooting. For example, an IT support team might be document step-by-step solution to common technical problems. Help then the members troubleshoot more efficiently and improve response at times for user issues. And these best practices help organizations operate more efficiently, maintain high quality service, and improve the overall experience for both internal teams and end users.
So we have in here the conclusion. Effective software troubleshooting requires a blend of technical knowledge, problem solving skills, and the use of appropriate tools and techniques. By following systematic steps, employing the right tools, learning from case studies, and adhering to best practices, developers and IT professionals can resolve software issues efficiently and improve overall software quality.